All right, starting with problem 17, it says the graph of a function f is shown above if the limit as x approaches b of f of x exists and f is not continuous at b, then what would b have to equal? So just a quick review, remember that since b right here in the limit statement does not, it's the target number, it does not have a superscript plus or minus on it. That means that it's a double-sided limit. And in order for a double-sided limit to exist, your left and right-sided limit have to approach both exist and approach the same thing, kind of like I'm showing you with my fingers here. And then I think you're pretty clear on what continuity is. So notice the word and. So I'm gonna actually start, if you're having a hard time understanding this one, I think it might be best if I start with a second statement. So where is f not continuous? So I claim it's not continuous at -1. It is not continuous at 0. I guess there's a 0 there. It's not continuous at 2. I just didn't like there's 0. Anyway, so you just have these 3 values where your graph is not continuous. And then now let's look at when does your double-sided limit exist or not. So at -1, your left-sided limit is -infinity and your right-sided limit is +infinity, so your limit would not exist at -1. At 0, your left-sided limit is 2 and your right-sided limit is also 2. So your double-sided limit at 0 would exist, and it's 2. So we have ruled this in, so I believe the answer should be B. But just to rule 2 out as your B value, while it is discontinuous at 2, your left-sided limit at 2 is 2, and your right-sided limit at 2 is 1, and so your double-sided limit would not exist there. So I hope that makes sense. Moving on to problem 18. My big tip for any problem that has a table, if you are struggling at all, would just be to sketch a graph out. And again, this is multiple choice, so it wouldn't have to win any awards or anything. So I'm gonna go ahead and sketch a graph out. I'm gonna use this kind of notation to say, hey, I'm starting here at 1. So let's make this 1.1, 1.2, 1.3, 1.4, 1.5, and so on. So. Okay, and then let's see the y values. Let's do a big jump here. Let's say this is 4, and then I'm going to make the jumps worth 0.2. So here's 4.2, 4.4, 4.6, 4.8, and so on. Okay, and then, again, if you're not sure what to do with something, just go ahead and plot things out. So put 1.1 a little shy of 4.2, 1.2 a little shy of 4.4, 1.3 a little shy of 4.6, 1.4 a little shy of 4.73. Okay, and as you can see, I have not gotten any better at graphing things. Okay, all right. But I'll just make the dots glob here. Okay, so it says, if you read this intro here, it says, let f be a function such that f double prime is less than 0. So what does that mean graphically if your second derivative is negative? It would mean that your graph of the function is concave down. So if you were to connect these dots, you'd want to make sure that you connect them with a concave down looking deal, and it says that it should be concave down all the way from 1 to 2, which would include the values that we've got plotted here. Select values of f are shown in the table above, which I've already graphed. Which of the following must be true about f prime of 1.2? It's going great, buddy. I'm almost done with this video. How are you doing? Good. I'm so glad. Okay, I can come up as soon as I'm done with this video, okay? It won't be very long. Let me think about that. I gotta finish this one though, okay? All right, okay, so notice that the options are all giving you some range for f prime of 1.2. So they're talking about the slope of the tangent line, okay? So Okay, so here's the deal. I hope you're okay with ruling option A out. F prime of 1.2 is not going to be a negative number. You can see that it's increasing from the picture, so A is definitely ruled out. Now, if you try to do the rule in, rule out stuff for the rest, it's going to be a little tough. So let's look at just the types of options. You know, is it bounded between 0 and 1.6? Is it bounded between 1.6 and 1.8? Between 1.8 and 2, or is it bigger than 2? So really probably the quickest way to land on it would be to look at your picture and figure, okay, well, if this graph is concave down, then what would the slope of the line be that goes from 1.2 to 1.3? And then I hope you guys are okay with like whatever the slope of that is, because the graph is concave down, that slope should be less, you know, than the slope that we're looking for. So if you were to do the slope formula between 1.2 and 1.3, you know, just subtracting, you know, do 4.56 minus 4.38 divided by, what would that be, 0.1. You'd end up with a slope there of 1.8. So the slope from 1.2 to 1.3 is 1.8. And then if you did the slope formula on, you know, the 2 points on the other side, hopefully from the picture, since the graph is concave down, you can see the slope of that tangent line would be greater than the slope of f prime, or of the tangent line at 1.2. So what's the slope there? 4.38 minus 4.18 divided by 0.1, you'd end up with 2. So if you look, just based on using the idea that this is concave down, and you could look and kind of see that the answer would be D. There we go. I hope that helps you guys. Take care.